Welcome to our channel. In this video, we are going to learn about what is immutable, how does it work, and why primitives are following the concept of pass by value and immutable. Let's see. As I said already, primitives are immutable, which means values once defined cannot be updated or modified. Let's see with an example. Before that, from our last video, we have seen what is primitive and what is pass by value. If you want to revisit, please click the I button here. We are continuing with the same example which we did in our last learning. I would like to do a quick recap about the code which we explained in the last video. We declared two variables, namely a and b. Then assigned value to a and reused value of a into b. Then we printed in the console. We demonstrated how data is stored behind the screen and how pass by value works. Now we are going to see about immutable and how it works. Let's update the value of a to 20. Then add the log message and rerun this program. Can you guess what will be the output? Let's check. If you can notice here, initially it was 10 and updated to 20. You may think that you have mentioned primitives are immutable, but how is it getting updated? What does immutability really mean here? Because when I assign a number to a variable and then update it to a different value, everything seems to work perfect. Then A is mutable, right? It is true that you are able to change the value of A from 10 to 20. But here it is important not to confuse a primitive with a variable assigned a primitive value. 10 is a primitive, whereas the variable a, which has a primitive value of 10, is not a primitive. It is just a variable that supposedly has a memory address of a primitive value. If it's still confusing, let me explain further. There is no way to change the value of 10 in the memory address that is referenced. The fundamental meaning of the value of 10 cannot be changed by you in the memory address. So, when we update the value of a from 10 to 20, what will happen behind the screen is 20 will be stored in the new memory address and the newly created memory address will be referenced with this variable a. So the old memory address of a is removed from a. Summing up, values are immutable, variables are not. They just hold a reference of their values. We will see about a combination of pass by value and immutable example. After updating variable a, then we print both a and b in the console and rerun this program. Can you guess what will be the output of b? You can find that it is 10. I just wanted to explain here again. When we assign or reuse an existing primitive value to a newly created variable or another variable, then the memory address of the value will be copied and referenced with the new variable. So the output of b will be 10 here until we update this variable. In this video, we have learnt about what is immutable and how it works. If you watched this and our last video about pass by value, you come to know that these two have a strong relationship between. Because of this, primitives always follow the concept of pass by value and immutable. So have in mind that whenever you are using any primitive data type, it always follows these two logics. In next video, we will see about types of primitive data types and its examples. If you have any question or suggestion, please comment in the comment section. We are happy to assist you. Happy learning.